Okay, so in this question they asked us to solve for a rational function, right? They've given us the form, so we have our two coefficients in front of x, and then two constants at the end. So essentially what we have is like two linear equations on top of each other. Okay, so they're divided by each other. They've told us that we have a vertical asymptote of 3 and a horizontal asymptote of 0, and the function is always increasing. So we want to try to make sense of this. We'll actually put a graph up here to help us out. So, from the information they gave us, we have a vertical asymptote at positive 3. Is that what it says? Okay. So we'll draw a line through that. Positive 3. We have our vertical asymptote. And we have a horizontal asymptote at y equals 0. Okay, well that's simple enough. And the function is always increasing, which means we're going to have a function that is essentially like this. It's a positive type function. Okay? So the only real requirements they've given us is our vertical asymptote. So we know which part of the rational function, the numerator or denominator, top or bottom?
Denominator.
Denominator. That's what the vertical asymptote deals with, right? So let's actually set that equal. We know that that part, we'll zoom in at the bottom, our vertical asymptote is going to be 3. Okay, so that means of our f at x, the denominator here cannot equal 3. Okay, so we can always work backwards. We know that our term, normally when we set these up, we would say x minus 3 cannot equal 0, right? But we could always work backwards from there to figure that out. In this case, x cannot equal 3, so we would reverse this. X cannot equal 3, so in order to set it equal to 0, because we know it can't be 0, we would bring the 3 back over, and when we bring the 3 back over, it becomes a negative term. Okay, so this so far would fulfill the bottom, our x minus 3. Okay, so we can go with that, x minus 3, that should be the bottom of our equation. And they've also told us that we have a horizontal asymptote of 0. So what does that mean as a horizontal asymptote of 0? And we don't technically need the brackets to start. What do we do to find horizontal asymptotes? Do you remember?
You divide the top x by the bottom x.
Mm-hmm.
But there's
Okay.
no x, right?
Okay, that's right. Because if we had an x value here, that'd be a coefficient of 1 and 1. And when we divide those coefficients, we get what? 1. So we actually need a coefficient of 0x, right? So we have a coefficient of 0x. Well, the 0 times x is 0. So essentially, we just have a constant term. In other words, they've given us the form at the top, ax plus b, cx plus d, right? So they had ax plus b, cx plus d. In this case, we called the c just value of 1, and the d negative 3. Here we need the a to be 0, and looks like we can call our b any term because they didn't really give us a requirement, so we'll just call it a simple term of 1. So in other words, the way this ends up laying out, 0x is 0, so we end up with 1 over x minus 3. And we could always plug that into something to figure out to make sure that was correct, right? We've tested it, it looks like it worked. We also have that program, remember I told you about. Let's see if we can't bring that up. The exact question, what did we say it was? 1 divided by x minus 3? So let's see if that fulfills our requirement. 1 divided by x minus 3. Okay? So there we go. It gives us our horizontal asymptote at 0, vertical asymptote at 3. But this guy is actually always decreasing, it looks like. Okay? So what we've got to do is go test that out and see what values are going to change for this. So in order to figure that out, we had to look at our values when we were to the left and to the right of our vertical asymptote at 3, right? So essentially, any value to the left, so less than 3, so we'll take a value like 2, and any value greater than 3, we'll take a value like 4, and we'll see what it creates in the equation we have, okay? So in the equation we had, if f was 2, we end up with 1 over 2 minus 3, right? Which just gave us a 1 over negative 1. So that gave us a negative term, which would be below the horizontal asymptote, so it would be decreasing. Same with that, our f at 4, same idea, 1 over 4 minus 3. 1 over 1, that gave us a positive value. So yes, that's the complete opposite of what we had here. So how can we go about changing that? How can we flip things? What part really is getting to us? The bottom part we really don't want to change because we know it has to be equal to 3. But we haven't done much with the top part. And what's getting to us is our dividing here at the end, right? We're dividing a positive by a negative. Well, since we're getting to choose whatever term we want on top, what would we like to do to that term maybe?
Make it negative.
Yeah, let's see if we can't make it negative. So if we make this term a negative, what's going to happen is we're going to have negative 1 divide negative 1. Well, that'll give us a positive 1. And here we'll have a negative 1 divide positive 1. That'll give us a negative 1 when we're to the right of it. So let's see if that changes it in our program when we're graphing. If we decide to make this 1 a negative, there we go, right? It's always increasing. Changes the question for us. So, just a couple of requirements we had to do. The one thing we forgot to check before we went into the program was the always increasing and decreasing, but we fixed it.